Okay, so let me share my screen. Can you see the screen? So if you can see the screen, say yes in the chat. If you cannot, say no. All right, yes, very good. Okay, so let's begin. So today we will be starting a new unit after we just finished Unit 5, which was Systems of Equations. This unit we will learn about factoring and polynomials. All right, so this is starting to get to the fun stuff of algebra. This is more advanced, much more advanced than the systems and the regular equations, but shouldn't be that hard. So this unit should be a little bit more challenging than the last units, but I think you guys can handle it. So let's start. First, of course, we're going to go back to the systems we learned. Just do a few review questions. Make sure you don't forget everything in that unit. And then I'm going to introduce factoring special expressions. And factoring is so there's a lot to factoring. So this lesson on factoring may be split across many lessons. All right, maybe 2 or 3 lessons. I'll be teaching factoring, and then we can finally teach a little bit about polynomials, and then we can start with quadratic equations, which is a little bit more advanced, right? And then lastly, we are going to have some practice problems at 0. But for this lesson, I'm going to do some examples after each topic. All right. So let's first go over this review problem. So we already went over this review problem in the last class, but I feel it'd be good to review it again because this was one of the harder ones. So let's just go over this one. All right. So I'll give you guys some time to think about it. And then we can post our answer in the chat. Dang it. I accidentally closed the thing again. Hold up. Let me start sharing, and then I'll get it out. Why does this keep happening? All right. Oh. Okay, I got it out. All right, so let's go back to that one slide. All right, there you go. So just do this. All right.
Boy.
Read that boy.
let's look at this one. Okay, so Grace's answer. All right, very good. Uh, Kaylee, we did not have homework last week because those are the second review. Yep. Okay, so let's go over this. So Malcolm and Ravi raced each other. Right, the average of their maximum speeds was 260 kilometers per hour. So Grace's answer is not very reasonable, right? Because if you add your answers up, right? What is this? 70 and 60. All right, Grace. So if you add it up, you get 130. And then you have to divide by 2 to get the average, which is at 75 or 65, right? So if their average is 65, which is not 260, then that means your answer is incorrect. So let's look at our other answer here. We have 200 and 320. See, the average of those two numbers is 260. So let's look at this. All right. So let's say Malcolm is M and Ravi is R. Okay. Their maximum speeds would be 80. So if doubled, Malcolm's maximum speed, so let's double it. All right, his maximum speed would be 80 more than Ravi's maximum speed. So we're actually not adding anything here. It's equal to R plus 80, right? And of course, besides that, we also have given information that their average is equal to 260. All right, so using our average formula, we can just say that R plus M over 2 is going to be equal to 260. All right, we know that. And then we can just solve. So I recommend just solving with, let's say, let's reformat this. All right, so let's make it this is going to be equal to 2m minus r is equal to 80, and then m plus r is going to be 520. All right, so what we did here essentially was we just rearranged the first equation and we multiplied 2 to both sides on the second equation. And then we can add, we see that the r's cancel out. You get 3m is going to be equal to 600. Therefore, m is going to be equal to 200 kilometers per hour, right? And we also know that 200 plus something over 2 is going to be 260, right? And they also add up to 520. And therefore, R is going to be equal to 320 kilometers per hour, right? So there we have it. Malcolm is 200 and Ravi is 320. All right, their maximum speeds, and we can probably infer that they're racing. They're doing something related to race cars. You know, can't possibly run that fast. All right, so let's do number 2. The sum of the digits of a certain 2-digit number is 7. Reversing its digits increases the number by 9. All right, so this is actually a little bit trickier. So make sure you read the problem carefully, and it is kind of tricky. So I'll give you some time to do that. All right, so hopefully some people have solved it. All right, so I think most of you got 34. So let's get someone up to volunteer for this one. Okay, so let's see. Who wants to volunteer to show their answer? Let's see who answered. All right. Who wants to volunteer? William, do you want to volunteer?
Okay, but I didn't really use algebra for it because I don't really know. I can't really think of an equation.
All right.
But I just yeah, but I just wait. So I just used the clues, and since if we reverse the numbers digits and it will increase the number by 9. So that just means the first digit is plus 1 is equal to the second digit, and the digits have to add up to 7. So I only got 3 and 4 for the digits. So the number has to be the smallest. Well, the smallest number has to be in the tens place. So the number has to be 34.
All right, that's a very reasonable solution. All right. If you were doing a math Olympiad on this, that would be the solution. That would be the way to go, right? So, right. So we could also, since we're learning how to do systems, we could also use like a solution, like to find the solution with a equation, right? But your solution is very good. All right. No problems with that. It's very fast and efficient, right? So let's see. I think Hugo gave us an equation. Okay. So I think your equation is pretty close, right? However, let's look at this a bit. So let's say we have the number AB, right? But they're AB are digits. They're not multiplying, right? So we know that A plus B equals 7, right? A plus B is equal to 7. And reversing its digits increases the number by 9. All right, so let's see. A plus, so Hugo gave us the equation B plus A is equal to A plus B plus 9. All right, but you see, B cancels out. A also cancels out. Then what do you get? You get 0 is equal to 9, which is not true. Since it's not true, then that equation is actually undefined. There's no solution for that. Therefore, we know that that is the wrong equation. So what really happens when you have a number? So let's say A, B, all right? This is a 2-digit number. What is B? B is in the units place, all right? So this is the units. This is the tens. So if you really need to find the value of the number, it's 10A plus B. If you add ABC here, if you add ABC, if you have C here, then A would be the hundreds, B would be the tens, and C would be the units. Then the actual value would be 100A plus 10B plus C, right? You get it, right? So essentially what we're doing here is if we reverse the digits, if B is in the tens, then the value of the number with the reverse digits would be 10B plus A is going to be equal to 10A plus B, which is the original number, then plus 9, right? So after we get that, we can, let's say we move it to the other side. We get A plus B is equal to 7. Then we get 9B minus 9A is going to be equal to 9, which is just B minus A is going to be equal to 1, since we divide everything by 9. and then we can add them. So therefore we get the a cancels out, but we get 2b is going to be equal to 8, right? 2b is going to be equal to 8, therefore b is going to be equal to 4, not 8. B is going to be equal to 4. All right, and since they add up to 7, a is also a is going to be 3. All right, so from this you can get 34. All right, so that is the algebraic way of solving it. It's not that hard, right? If you know how to like denote that, right? So Grace, that's a very good equation. Yes, that is exactly what I did there, right? So very good, Grace. And William, your solution was very good too. All right. So if you're doing this for like a math Olympiad or like a competition, you want to do it fast, right? I suggest using William's method. But if you're learning this algebraically, you can also use like a system, right? You can also use a system.
Wait,
All right, so
I didn't really get the algebra.
you didn't get the algebra. This is Google, right?
Yeah.
Oh, so what part do you not get?
That 9b minus 9a equals 9.
Oh, we just subtracted.
Oh,
Oh, you get it now?
yeah, I get it now.
All right, very good. So let's look over 3, right? The difference of two numbers is 9. Their sum is 5. Find the number. This is a pretty easy one. All right, so I hope everybody got a chance to do that. So let's look at this. All right, so the two numbers are 7 and -2. Very good, very good. Kaylee, did you mean to do 2 and -7 or -2 and 7? Might have been a small mistake there, but it's fine. Okay, so actually, if you think about it, hold up. 2 and -7. Oh, yeah. Yep, okay. So the difference of two numbers is 9. Their sum is 5. Okay, so let's do this. Let's say x is the larger one, y is a smaller one. So you get x minus y is going to be equal to 9, and their sum x plus y is going to be equal to 5. Right? If we add them, you see the y's cancel out, right? It's negative y plus y, so they cancel out. Therefore, we get 2x plus 4. Well, not plus. Is equal. 2x is equal to 14, right? Therefore, we get x is going to be equal to 7. And you know the sum is 5, right? So the only number y can be is -2, all right? So therefore, we get 7 and -2 are our answers. All right, very good. So let's go over some of the new material. Okay, some of the new material. So today we're going to be learning factoring. All right, factoring. So what is factoring? Factoring is rewriting a mathematical identity as a product of two or more less complex identities. So let's take a number. Let's say, what's a number with a lot of factors? Let's say 36. All right. So can everybody in the chat just list some of the factors of 36? All right. Can everybody just start listing factors of 36? All right. That's our example. All right. So 9 and 4. Very good. Very good. So are there any other factors? Right. I know there are other factors. How many factors can we list? We have 3 and 12. Very good. We have 1, 36, 9, 4, 12, and 3, right? So there's a lot of factors. Okay, we have a lot of factors. So thank you, everyone. Okay, so let's take any of these two factors that multiply to 36. So we can say from all these factors, 36. All right, just pick two of them that multiply together. Let's say 2 times 18. All right, this 36 would be the mathematical identity that we're representing as a product of two or more smaller identities, right? So we could say that this is factored, right? We can go even farther and take the prime factorization, right? So this can be we could say this is a factor form of 36, right? So we can do that with a lot of we can do that with real numbers like this, right? Or integers, right? So if we do another example, we could say that for example, we could also say 24 is going to be equal to 4 times 6. 15 is equal to 3 times 5, right? We can factor that a lot of ways, right? And we already know that, right? A lot of us, most of us should know that we can factor it like that, right? Because you learn this in like elementary school, right? It's very basic stuff. But now we're taking it to a different level, right? How do you factor something like this? How do you factor something like x squared plus 2xy plus y squared, right? How do you factor something like x squared plus 3x plus 2, right? So we're getting into more complex stuff with algebra, right? We're getting into variables, we're getting x, all types of exponents, right? But we still need to factor it, right? For example, x cubed minus y cubed, how do you factor it? It's x minus y times x squared plus xy plus y squared. How did I get this? All right, this is called difference of cubed, and I'll teach you the formula later. All right, and this is x plus y squared. This is x plus 2 x plus 1. All right, so we can factor it, right? So how do we do that? Essentially, factoring algebraic expressions is the same as factoring known identities like the integers that we just went over, like 15, 24, and 36, right? So the big idea when you're factoring algebraic expressions, and you gotta factor completely, right? If you factor if you're not factoring completely, it's still not simplified, right? So you gotta find a common factor that is the greatest, right? You gotta find the greatest common factor, and that's the key point of factoring algebraic expressions. Essentially, it's the same as factoring all of these integers, right? We're also similarly finding common factors, right? So what does it mean to have common factors? So let's look at something like this, all right? Let's look at ax plus by, all right? So not by, we can't actually factor that. Let's say ax ay. All right, so let's look. So we need to find the greatest common factor, and let's look at all of these, each of these terms. All right. So each term, we know that it's a different term when it's separated by something like addition or subtraction. All right. When something's like when it's like a times x or a divided by x, we know that that whole thing is a term because it's connected with multiplication and division. However, a term when it's separated by addition or subtraction, we know they're different terms. All right, so we can say that there are two terms here. So for each of these terms, let's look at each of these objects inside the term. Usually terms are in algebraic expressions, for example, like ax cubed plus bx plus c, right? Each of these terms have multiple objects multiply within it. We got a, got x's, we got b's, we got x, right? So let's look at each of these terms. We've got a's, right? We've got one a in this term. We got x's, we got one x, we got a's, we got y's, right? So essentially, you're finding which factors do both these terms have in common. All right, so you're finding what you're finding is you're finding which factors each of each of the terms have in common. All right, that's what you're doing. You're finding which factors each of the terms have in common. All right, so let's look at this. So ax, how many a's does it have? It has one a. Has one a. All right, how many x's? It's one x. What about a y? It has one a also. It also has a y. All right, so how many a's can you take from each expression? You can take one a from each expression. So let's pull that out. So basically, we're going to rewrite this. All right, we're going to rewrite this as a times x plus y. All right, if you use distributive property to multiply it again, you can see that it's exactly the same. But we're just basically we're dividing a from each of these ax, ay, all right? And we're just pulling it out. We're pulling a out, all right? Now, why didn't we pull x out? That's because we can't pull x from each term equally, right? We can't pull an x from ay because there simply is no x, right? For example, if you have 6x plus 10, you can't pull the x from 10, right? Because there is no x in 10. So we can only pull the a out, all right? then this is the factor form, a times x plus y. All right, does everybody understand basically what that was talking about? Does everybody understand? Say yes in the chat if you understand. If you have any questions, you can also post those in the chat. So does everybody understand? All right, yes, very good, very good. Okay, so let's move on to some examples. All right, so let's look at this one. All right, I'll give you guys some time to try and solve this. So factor completely. All right, factor this completely. All right, so let's look at this. Let's see what you guys came up. All right, so 12 times 2x minus 3. All right, I see a lot of you guys put in 2x minus 3. Do not do that because that is not equal to the original value, right? Because factoring does not change the value of this expression, all right? It's the same. So when you multiply out using distributive property, it should be the same expression. So don't forget to include the 12. Right. So first, let's look for some greatest common factors. 24 and 36. What's the greatest common factor? And that's 12. Right. If you list their factors, you can see that their greatest common factor is 12. So let's just factor that out. Right. Let's pull a 12 out. So what multiplied by 12 is equal to 24x? That's going to be 2x, right? And if you pull 12 from 36, that's going to be 3, right? So if you want to check your answer, you can multiply out again to see if it is correct. All right. So let's move on to the second one. Just a little hint, you can see all these terms. You got what do we have? We have integers or numerals, the numbers. We have x's, don't forget the x's. We have y's. You've got three different factors here. So let's see how much of each factor can you pull from each term. All right, so that's my little hint. All right, I'll try to do the problem. So let's see what everybody came up with. So we have 2 times 2x to the third y minus 3x y to the third plus 9. All right, see if that's correct. All right, so let's so everybody participate in the chat. All right, so everybody participate. Let's look at each term here. All right, 4, 6, and 18. All right, 4, 6, and 18. What is the greatest common factor of 4, 6, and 18? Does anybody know the greatest common factor of 4, 6, and 18? Very good, it's 2. So all you need to do is to pull out the 2 there, right? Minus 3x squared y to the third plus 9. Can you do anything further? You can't, because how many x's can you pull out? Can't do anything because there's a 9. The 9 doesn't have an x or a y. All right, so that's the farthest you can go. That's the farthest you can go. All right, so let's look at number 3 here. You might wonder, how can you factor number 3? The thing is, you can't pull out a number, you can't pull out an x, you can't pull out a z, you can't pull out y. This is not factorable. All right, and what happens when it's not factorable? When it's not factorable, we can call it prime. All right, so this expression is prime to its integers. All right, so you cannot factor it. All right, so we call this prime. All right, so sometimes you just cannot factor, and it's in its simplest form already, right? So now I'm going to have to go over some more advanced factoring. All right, so let's factor some expressions of the form x squared plus bx plus c. So what you need to do is you need to look at this c, right? You have to look at the c. All right, list factors or think of factors of the c. All right. Okay, if you can list factors of c, all right? So once you list factors of c, all right, once you list factors of c, choose two that add up to b. That add up to b. All right, choose two factors of c that add up to b. All right, there should only be two. All right, then the factored form should be x plus factor 1 and then x plus factor 2. All right, we can denote these two factors as factor 1, factor 2. All right, so let's do it with an example. All right, so let's look at this example. Maybe uh, let's say x squared plus maybe since we did that example on 24 earlier, let's do it x squared plus 11x plus 24. Can you factor this? Yes, you can factor this. So you got to look at the c term. So you can see that a, all right, normally we have something like this. We have an a term, right? Maybe 3x plus 11x plus 24, but right now we don't know how to factor an ax plus bx plus c. This is we're gonna work with a special case that a is gonna be equal to 1, therefore there is no a, right? So it's just x squared plus bx plus c. So let's work with this special case first. So all you need to do with this case is you got to list factors of c. All right, so everybody list factors of c. Okay, it's 3 and 8, right? Very good. So this is equal to 3 times 8. And you see they also add up to 11, which is perfect, right? They also add up to 11, which is perfect. Very good, Kaylee. All right, so let's say you choose 2 and 12, right? They also multiply to 24, except when they add them up, they equal 14, which doesn't work out. So 3 and 8 is the correct answer. So how should we factor this? After we get our two factors, it should be x plus f1 times x plus f2, right? So this should be x plus 3, x plus 8, all right? If we multiply it out, does anybody know how to multiply this out, all right? If you multiply this out, this is the same as a distributive property, all right? So essentially what we're doing here is x times x plus 8 plus 3 times x plus 8, right? So using the distributive property, all we're doing is using this distributive property. So when you're multiplying these things out, don't be scared of this. It's quite easy. So all you do have to multiply the x with both of these terms on the right, and then multiply the 3 with both of these terms on the right, and then you get x squared plus 11x is going to be equal to 24. All right. So not only will we be learning how to factor, we'll also be learning how to multiply as a byproduct, right? But multiplying is pretty trivial, so it's pretty easy to learn. So
Wait, how did the 3 and 8 end up right there? Like x squared plus 11x plus 3 times 8. How do you like distribute the x?
but
Like how did you distribute the x? Because
okay. So with this spectral form, okay, don't use it with 3x plus 11x plus 24. It wouldn't work. But if it's x squared, 1 times x squared, then all you need to do is come up with two factors that add up to b and multiply to c. Then it's x plus f1 times x plus f2.
oh, okay.
It's always this way if it's x squared. However, you cannot do this with like 2x squared or 3x squared. Only when it's x squared, just x squared. All right. So
Get it.
yep. Okay, so let's do some useful. Let's give you some useful formulas. All right, let's use some useful formulas. All right, so what are some useful formulas? All right, so this you can memorize these. All right, memorize these, and then whenever you see one of these cases, you can just straight up. You don't actually think about factoring. You already know what it is. So first off, let's go with x plus y. Actually, let's do this. Actually, let's x plus y. What is x plus y squared? X plus y squared is going to be equal to x plus y times x plus y, not x squared plus y squared. That is the dumbest mistake to make. Don't do that. All right. So it is x plus y times x plus y. If you multiply these terms here using distributive property, you get x squared plus xy plus xy plus y squared, right? So therefore you get x squared plus 2xy plus y squared. In a real life example, without y, you could see that x squared plus 4x plus 4, this is going to be essentially just x plus 2 squared, right? That is our example there. All right. So I have the x minus y squared. So I have x minus, okay, my battery is very low. Let's see how low it is. Probably super low. Might need to, I don't even know. Hold up. Battery. 13% available. It's fine, it's fine. All right. Okay, so x minus y squared, all right? It's essentially the same as x plus y squared, except you're going to get x squared minus xy plus y squared. Essentially, it's x squared minus 2xy. Instead, it's minus 2xy plus y squared, right? Let's have an example of this. So if it's x squared, let's say minus 6x plus 9, basically what you have is x minus 3 squared, right? And once you start working more with these, you'll begin to be able to recognize them more, right? You'll be able to recognize, oh, instantly, that's x minus 3 squared. Instantly, that's x plus 2 squared, right? Once you start working with these, you'll recognize them more, so don't feel pressure to memorize all of them right now. Okay, so last one we can do here is x plus y, x minus y. Okay? And this is called difference of squares. This is really useful. So let's look at what it is. It's x squared plus xy minus xy plus y squared. You can see that XY cancels out, which is really useful. So if you see X plus Y and then X minus Y, it's just X squared. Actually, no, this is minus XY. It's just X squared minus Y squared, right? It's X squared minus Y squared. That's why it's called difference of squares. So this is really useful. The XY cancels out, right? So incredibly useful. Okay, so if you can't ever like, for example, if you ever have X squared minus 9, it's just, you see, 9 is a perfect squared, X is a perfect square, therefore it's X plus 3 times X minus 3, right? So it's very useful, very useful. Instantly you can tell what it is. So let's just go over these real quick, because we're running out of time. Let's just go over these. All right. So for this one, what we need to do is we need to list factors of 2 first. Yet there are only about like 4 factors of 2. It's -1, -2, 1, and 2. Right? And we need to find 2 factors that actually add up to 3. So the negatives are already out. So you're just left with 1 and 2, and they do add up to 3, right? So then you get X plus 1 and X plus 2. So once you get these 2 factors, you can just put it in the form X plus F1 times X plus F2, right? It's very convenient. It's very convenient. All right. So number 2 here, we already talked about this in our useful formulas. You can see why this is useful, right? If you find 2 factors of 9, you can see that it's 3 times 3, right? And that adds up perfectly to 6. So you actually get X plus 3 times X plus 3, which is equal to X plus 3 squared. So that's why you need to know the formula X plus Y squared, right? It's very useful. And lastly, this one is a little bit more challenging, but not that much. All right. So let's look at each of these terms here. And each term has 2 objects, 2 factors in it. First, we got the numbers, right? We got the numbers and we got the x's, right? So what is the common factor of 2, 8, and 6? It's pretty obvious. It's 2. So let's pull a 2 out. And we're not done yet. What about the x's? What is the most x's you can pull out from every single one of these terms? So can everybody try to answer that? What is the most amount of x's we can pull out?
3.
X cubed, right? Very good, Hugo. It's x cubed. All right. It's x cubed. So it's 2x cubed. You can pull out 2x cubed from each of these terms. So what do you get? From the first equation, you get x squared. From the second equation, you get minus 4x. And then from the third equation, you get plus 3. Are we done? We're not done. We're not done. We can still factor further. You can factor further, right? You can factor further. So how do you factor this? Let's look at factors of 3. All right, you got -1, right? -3, 1, and 3. Since we know it's they add up to -3, the positive ones are out. All right, they're not it. They're not it. All right, and we also know that 2 negatives multiply to make it a positive, right? So you know that it's -1 and 3, -3. All right, and they do add up to -4, our B term, right? All right, so we get 2x cubed times x minus 1 and times x minus 3. So does everybody get this answer? Does everybody get this? Are there any questions? All right, yes, Hugo, very good. So if you get it, say yes in the chat. If you fully understand. All right, yes, very good, Kaylee. All right, so hopefully you should get it. All right, I'm seeing a lot of yeses. Very good. Okay, so that was the last example. All right, we're already out of time. Okay, so thank you for listening today, and I'll see you next week. All right, so I'll be posting the homework shortly on the Google Classroom. So make sure you do that. Okay. All right. See you next week.